Assalamualaikum warahmatullahi wabarakatuh. Thanks for all of you for watching my video. In this video, I want to presentation Project 1, Vector Calculus. Before of that, let me introduce myself. My name is Danisa Alzura Olpelda and my student ID number is 200300032 and I'm from Math Training International. In this material, there are three subjects, such as first, vector in R2 and R3, second, the dot product, and the last one, the cross product. Okay, the first material about vector in R2 and R3. Vector addition, rule of triangle. If U and P are vector positions, so that the starting point of P is at the terminal point U, then the sum of U plus P is the vector from the starting point U to the terminal point P. Rule of parallelogram. Here, we start with the same vector U and P as before and draw an other copy of P with the same starting point as U. Completing the parallelogram, we see that U plus P is equal to P plus U. Scalar multiplication. If K is a scalar and P is a vector, the scalar multiple of P is a vector whose length is mutlak C times the length P and the direction is the same as P if C is more than 0 and opposite to P if C is less than 0. If C equal to 0 or P equal to 0, then CV is equal to 0. In particular, the vector minus P is equal to minus 1 multiplied by P, has the same length as P, but points in the opposite direction. We call this the negative of P. Vector subtraction. Subtracting U minus P from two vectors, what it means is U minus P is equal to U plus minus P. So, we can construct U minus P by first drawing the negative of P minus P and then adding it to U with the law of parallelogram. Vector length. The length of the two-dimensional vector A is equal to A1, A2 is mutlak A is equal to root of A1 square plus A2 square. The length of the three-dimensional vector A is equal to A1, A2, A3 is mutlak A is equal to root of A1 square plus A2 square plus A3 square. Vector algebraic three-dimensional. This we can see in this PDF. Example, if A is 608 and B is minus 215, find mutlak A and vector A plus B, A minus B, 3B, 2A plus 5B. Solution. Mutlak A is equal to root of 6 square plus 0 square plus x square is equal to root of 100 is equal to 10. And A plus B is equal to 608 plus minus 215. This is we addition to vector become 6 minus 2, 0 plus 1, and 8 plus 5 is equal to 4, 1, and 13. A minus B. We have the result is 8 minus 1 and 3. Then 3 times B is equal to minus 6, 3, 15. And 2 times A plus 5 times B is equal to 2, 5, and 1. Vector properties. If A, B, and C are vector in Pn and C and B is a scalar, then first, A plus B is equal to B plus A. Second, A plus B plus C is equal to A plus B plus C. Third, A plus 0 is equal to A. Fourth, A plus minus A is equal to 0. 5, C times A plus B is equal to C times A plus C times B. 6, C plus B times A is equal to C times A plus B times A. C, B times A is equal to C times BA. 1 times A is equal to A. Vector unit. In general, if A is not equal to 0, then the unit vector in the direction of A is mutlak U is equal to 1 per mutlak A times A is equal to A per mutlak A. Example, find the unit vector in the direction of vector 2i minus b minus 2k. Solution, the given vector has length mutlak 2a minus b minus 2k is equal to root of 2 square plus minus 1 square plus minus 2 square is equal to root of 9 is equal to 3. So, by equation 4, the unit vector in the same direction is 1 per 3 times 2i minus b minus 2k is equal to 2 per 3e minus 1 per 3b minus 2 per 3k. Vector application. Example, a 100 lb weight is suspended from the center of a stone in the figure. Determine the tension P in the rope. So this is the figure. What the problem means. And the solution is from the figure. We see that K1 is equal to minus mutlak K1 cos 50 E plus mutlak K1 sin 50 E. And P2 is mutlak P2 cos 32 E plus mutlak P2 sin 32 E. So we have P1 plus P2 is minus W is equal to 100. So we can get the equation. We can get this equation. And equation the components, we get this. Okay, the first step, we solve the first equation mutlak T2 and replace the second equation. Then T1 sin 50 plus mutlak T1 cos 50 per cos 32. Times sin 32 is equal to 100. So the magnitude of the voltage is this. We have the result is for the mutlak T1 is 85.64 LB. And for T2, sorry, this is mistakes. It means mutlak T2 is equal to 64.91 LB. We see that T1 is equal to minus 100 cos 5t E plus 100 sin 5t G. T2 is 100 cos 32E plus 100 sin 32G. Next, we substitute the value of cos 50, sin 50, cos 32, and sin 32. And we get the tension T is T1 is equal to minus 55.05 E plus 65.60 G. And T2 is 55.05 E plus 20 plus 34.40 G. Okay, the next material about the dot product. Definition. Theorem 1. If A is equal to A1, A2, and A3, and B is equal to B1, B2, B3, then the dot product of A and B is the number A times B given by A times B is equal to A1 times B1 plus A2 times B2 plus A3 times B3. For the next example, if we have two vector is 1, the first vector is 1, 3, and 4 times by the second vector is 5, 2, and 1. So we can solve this with this equation in theorem 1. So we get 1 times 5 plus 3 times 2 plus 4 times 1 is equal to 10. And second example is the same for the first example. Properties of that product. Theorem 2. If A, B, and C are vector in P3 and C is scalar, then first A times A is mutlak A squared. A times B is equal to B times A. A times B plus C is equal to A times B plus A times C. C A times B is equal to C times AB or A times CB. 0 times A is equal to 0. Theorem 3. If theta is the angle between the vector A and B, then A times B is equal to mutlak A times mutlak B cos theta. Example, if the vector A and B have length 4 and 6, and the angle between them is P per 3, find A cross find A dot B. Answer. I'm sorry before my pronunciation before it means dot. Answer. A dot B is equal to mutlak A times mutlak B cos P per 3 is equal to, we enter the value of A and B is 4 and 6 in the list. So we get the result is 20. So we get the result is 12. Non-zero vectors. Theorem 4. If theta is the angle between the non-zero vector A and B, then cos theta is equal to A dot B per mutlak A mutlak B is, so we can have theta is equal to cos minus 1 A dot B per mutlak A mutlak B. Example, find the angle between the vector A, 2, 2, minus 1, and B, 5, minus 3, and 2, and so on. We get the result for unit for mutlak A is 3 and mutlak B is root of 38. 38. Also, we have A dot B is equal to 2. From the theorem for thus, cos theta is equal to 8 times B, we get the result is 2, and with this we get the result is 3 and root of 38. So we substitute the value of this equation. So we get cos theta is equal to 2 per 3 root of 38. So the angle between A and B is theta is equal to cos inverse 2 per 3 root of 38 is equal to 1.46 or 84 degrees. Orthogonal vector, theorem 5. Two vectors A and B are orthogonal if and only if A dot B is equal to 0. Example, so that 2E plus 3G plus 5K is perpendicular to E plus 2G minus 2K. Answer. We need to prove that two vector is orthogonal, so we have to show that the dot product of the vector is 0. And 2A plus 3B minus 4K dot E plus 2B plus 2K is equal to 2 times 1 plus 3 times 2 minus 4 times 2. We get the result is 0. So we can see that these vectors are perpendicular. Projection. The component of B along A can be computed by taking the dot product of B with the unit vector in the direction of A. So we have scalar projection of B onto A is project AB is equal to A dot B per mutlak A times A per mutlak A is equal to A dot B per mutlak A square times A. Vector projection of B onto A, com AB is equal to A dot B per mutlak A. Notice that the vector projection is a scalar projection times the unit vector in the direction of A. Example, find the scalar and vector projection of A. Of A is 112 onto B minus 231. Answer. We have the mutlak A is equal to root of 14. So the scalar projection of B onto A is com AB is we need to substitute the value to this equation. So we get the ratio. The result is 3 per root of 14. So the scalar projection of B onto A is project AB is equal to 3 per square of 14 times A plus mutlak A. So it's equal to 3 plus root of 14A is equal to minus 3 per 7, 9 per 14, 3 for 14. Application of projection. The work done by a constant force P is defined to be the dot product P dot P of the component of the force along B and the distance moved, where D is the displacement vector. So W is equal to mutlak P cos theta is equal to P dot P. Example, a wagon is pulled a distance of 100 m along a horizontal path by a constant force of 70. and 70 newtons. The handle of the wagon is held at an angle of 35 above the horizontal. Find the work done by the force. So we have the figure, the cross product. The next material about cross product. Definition. If A is equal to A1, A2, and A3, and B is equal to B1, B2, B2, and B3, B3, then the cross product of A and B is the vector A cross B is equal to A2 times B3 minus A3 times B2, A3 times B1 minus A1 times B2, A1 times B2 is equal to A2 times B1. In order to make theorem easier to remember, we use the notation of determinant. So this is the notation of determinant. We know from the last lesson. We see that the cross product of the vector A is equal to A1E, A2G plus A3K, and B is equal to B1E plus B2G plus B3K is this. We can see in this PPT. Then we write that A cross B is determinant of B, A1, B1, B, A2, B2, K, A3, B3. Example. If A is equal to 1, 2, 3, and B equal to 2 minus 1 and 4, then A cross B is equal to B1, 2, B2, 7, K4 minus 5. So, from the determinant of this, we can get a result is minus 43B plus 13B plus K. Theorem 1. The vector A cross B is orthogonal to both A and B. A cross B times A is equal to 0. Theorem 2. A similar computation shows that A cross B times B is 0. Therefore, A cross B is orthogonal to both A and B. Theorem 3. If theta is the angle between A and B, so theta more than or equal to 0 and theta is less than or equal to T, then mutlak A cos B is equal to mutlak A mutlak B sin theta. Theorem 4. Two non-zero vector A and B are parallel if and only if A cross B is equal to 0. Example. Find a vector perpendicular to the plane that passes through the point P1, 2, 3, P2, 1, 3, L4, 5, 6. Solution. The vector is perpendicular to both PQ and PR. PQ is 2 minus 1E plus 1 minus 2G plus 3 minus 3K is equal to E minus P. PR is equal to 4 minus 1E plus 5 minus 2G plus 6 minus 3K is equal to 3E plus 3J plus 3K. We compute the cross product of this vector is PQ cross PR is equal to E13, K minus 13, K03. So, we determine that, so we get the result is minus 3E minus 3K. Therefore, the vector minus 3 minus 3 is perpendicular to the given plane. Example. Find the area of the triangle with surface P123, P213, L456. Solution. P PQ cos PL is equal to minus 3E minus 3J. This is from the last example, the before example. You can see before. The area of the parallelogram with adjacent sides PQ and PR is the length of this cross product. Mutlak PQ cos PR is equal to 3 root of 2. The area A of the triangle PQR is half the area of this parallelogram, that is 3 per 2 root of 2. Properties of cross product. If A, B, and C are vectors and C is a scalar, then A cross B is equal to B cross A. C times A cross B is equal to C times A cross B, or A times A cross CB. A cross B plus C is equal to A cross B plus A cross C. A cross C. A plus B cross C is equal to A cross C plus B cross C. A times B cross C is equal to A cross B times C. A cross B cross C is equal to A times B minus A times BC. Scalar triple product. We can write the scalar triple product as determinant is A times B cross C. With this, we can see the hence the volume of the parallelogram is P is equal to A bar is equal to B cross C, mutlak B cross C, mutlak A, and mutlak cos theta. So, is equal to mutlak A times B cross C. The volume of the parallelogram determined by the vector A, B, and C is the magnitude of the scalar triple product. P is equal to A times B cross C. If the volume of the parallelogram is 0, then the vector must lie in the same plane, so the parallelograms are coplanar. Example, use the scalar triple product to show that the vector A1 4 minus 7 B 2 minus 4 C 0 minus 9 18 are coplanar. Solution: A times B cross C is equal to 1 to 0, 4 minus 1 minus 9, minus 7, 4, 18. So with the B determinant this, so we get the result is 0. This means that A, B, and C are coplanar. Cross product application. Torque Q. The torque Q is defined to be the cross product of the position and force vector. Torque Q is equal to R cross P. The magnitude of the torque Q vector is mutlak P is equal to mutlak R cross P is equal to mutlak R mutlak P sin theta, where theta is the angle between the position and the force vector. You can see this figure. Example, a bolt is tightened by applying a force P and force to a 0.25 M branch. Find the magnitude of the torque Q of the center of the bolt. This is the figure. Solution. Mutlak torque Q is equal to mutlak R cross P is equal to mutlak R mutlak P sin 75 is equal to 0.25 times 40 sin 75. So we get the result is 9.66 Nm. So the magnitude of the torque Q is 9.66 N. I think that's all the material. That's all the material we can discuss. If there are mistakes, please forgive us. I end it with wassalamualaikum warahmatullahi wabarakatuh.